Hello students, I am Dilip Udani, Assistant Professor at LJ Institute of Engineering and Technology. In partial derivative today, I will teach you first order partial derivative. So first of all, what is partial derivative? So before going into the detail of partial derivative, first of all we need to understand what is an ordinary derivative. In case of single variable function, for example, say y is a function of x. So this is a single variable function. So in this case, we will use ordinary derivatives. But in case of a function which is of two or more variable, for example, u equals to say x square plus y square. So it is a function of two variables. So in this case, we will find out partial derivative. So in this lecture, I will make you understand how to find out first order partial derivatives. So let's start. So first of all, we will see what is first order partial derivative. The partial derivative of u equals to function of xy with respect to x is the ordinary derivative of u with respect to x, keeping y constant, and it is denoted by del u by del x or del f by del x or ux or fx, and is known as first order partial derivative of u with respect to x. This is del u by del x, that is equals to limit h tends to 0 function of x plus h comma y minus function of x comma y divided by h. So first of all, what is dy by dx? So dy by dx, that is nothing but change in y when there is a change in x. So what will be del u by del x? So del u by del x, that is nothing but change in u when there is a change in x but keeping y constant, right? So that is function of x plus h comma y minus function of x comma y. This is nothing but change in u keeping y constant. So this is the definition of del u by del x using limit. Now similarly, the partial derivative of u, that is equals to function of xy with respect to y, is the ordinary derivative of u with respect to y, keeping x constant, and it is denoted by del u by del y or del f by del y or uy or fy, and is known as first order partial derivative of u with respect to y. That is del u by del y, that is equals to limit h tends to 0 function of x comma y plus h minus function of x comma y divided by h. So del u by del y, that is nothing but the partial derivative of u with respect to y keeping x constant. So function of x comma y plus h minus function of x comma y, that is nothing but change in u when there is a change in y keeping x constant. Now we will see example related to this topic. If function of xy equals to x square y plus xy square, then find fx at 1 comma 2 and fy at 1 comma 2 by definition. Here function of xy is x square y plus xy square. We have to find out del f by del x at point 1 comma 2 and del f by del y at point 1 comma 2 using definition. So applying the definition of del f by del x using limit, that is del f by del x equals to limit h tends to 0 function of x plus h comma y minus function of x comma y upon h. So first of all, we have to find out function of x plus h comma y. To find out function of x plus h comma y, we have to replace x by x plus h in the function of f x comma y. So replacing x by x plus h, limit h tends to 0, replacing x by x plus h, so it will be x plus h the whole square and y will be as it is. Then after plus sign, second term is xy square, so replacing x by x plus h and y square is same. Then after minus function of x comma y, and function of x comma y is x square y plus xy square, but outside there is a minus sign, so it will become minus x square y minus xy square divided by h. Now we have to simplify this result. So on x plus h the whole square, we will apply the formula of a plus b the whole square. that is a square plus 2ab plus b square, right? So x plus h the whole square, that will be x square plus 2xh plus h square. Now multiplying this result by y, so we have x square y plus 2xhy plus h square y. Then after we have to multiply x plus h by y square. So it will be x into y square, then after plus h into y square. Then after minus x square y and minus xy square will be as it is and divided by h. Now we have to simplify this result. So you can see x square y and x square y will cancel out. Similarly, xy square and xy square will cancel out, and the result is limit h tends to 0, 2xhy plus h square y plus hy square upon h. Now taking h common from the numerator, so h from the numerator and denominator will cancel out, and the result is limit h tends to 0, 2xy plus hy plus y square. Now we will put value of h equals to 0, so it is 2xy plus y square, because if you will put down the value of h equals to 0, so 0 into y, the result is 0. So we have del f by del x, that is equals to 2xy plus y square. But we have to find out del f by del x at point 1, 2. So in this del f by del x, 2xy plus y square, we will replace x by 1 and y by 2. So this is equals to 2 into replacing x by 1, replacing y by 2 plus replacing y by 2 square. So it is 2 2s are 4 plus 2 square is 4. So the answer is 4 plus 4, that is equals to 8. So this is del f by del x at point 1, 2. Now similarly we will find out del f by del y at point 1, 2. So first of all we will find out del f by del y using definition, and that is limit h tends to 0, f of x comma y plus h minus f of xy upon h. So first of all we have to find out f of x comma y plus h. So to find out f of x comma y plus h, we will replace y by y plus h. So limit h tends to 0, x square will be as it is, replacing y by y plus h, then after x will be as it is and replacing y by y plus h, so it will become y plus h the whole square. Then after function of xy will be as it is and multiplying it by minus sign, so the result is minus x square y minus xy square divided by h. Now we have to simplify this result. First of all we will multiply y plus h by x square, so it will become limit h tends to 0, x square y plus x square h. Then after we will expand y plus h the whole square according to the formula of a plus b the whole square, that is a square plus 2ab plus b square. Then after we will multiply the result x. So the result is x into y square plus 2xy into h plus xh square. Then after minus x square y minus xy square will be as it is. Now we have to simplify this result. You can see that x square y and x square y will cancel out, and also xy square and minus xy square, that will cancel out. So the simplification is limit h tends to 0, x square h plus 2xyh plus xh square divided by h. Now we will take h common from the numerator. So taking h common, and in the denominator we have h, so that will cancel out. So we have limit h tends to 0, x square plus 2xy plus xh. Now in this function we will replace h by 0 to evaluate the limit of this function. So the result is x square plus 2xy. This is del f by del y. But we have to find out del f by del y at point 1, 2. So replacing x by 1 and y by 2 in del f by del y. So that is equals to fy at 1, 2, that is equals to 1 square plus 2 into 1 into replacing y by 2. So the result is 1 plus 4 plus 5. So this is del f by del y at point 1, 2, and the result is 5. So in this example we have gone through how to find out del f by del x and del f by del y using definition. Now we will see example number 2 related to this topic. Example number 2 is find the values of del f by del x and del f by del y at the point 4 comma minus y if function of xy is x square plus 3xy plus y minus 1. So here the function of xy is x square plus 3xy plus y minus 1. So first of all we will find out del f by del x. Here it is not defined that we have to find out del f by del x and del f by del y using definition. So directly we can find out del f by del x. So for the first term x square, derivative of x square with respect to x, that is 2x, according to the formula d by dx x raised to n, that is equals to n into x raised to n minus 1. So derivative of x square is 2x, and for the second term 3xy, 3y is constant because here we have to find out del f by del x. It means we have to keep y constant. So 3y is constant and derivative of x with respect to x, answer is 1. Then after y and minus 1 both are constant, so its derivative will be 0. So this is del f by del x, that is equals to 2x plus 3y. Now we have to find out del f by del x at point 4 comma minus 5. So in del f by del x we will replace x by 4 and y by minus 5. So that is equals to 2 into 4 plus 3 into minus 5. 2 into 4 result is 8. Then after 3 into minus 5 result is minus 15. So 8 minus 15, that is minus 7. So del f by del x at point 4 comma minus y, answer is minus 7. Now similarly we will find out del f by del y. So to find out del f by del y we will keep x constant. So for the first term x square, right, x is constant, so derivative of x square will be 0. Then after for the second term 3xy, 3x is constant and derivative of y with respect to y, answer is 1. So 3x into 1, answer is 3x. Then after derivative of y with respect to y, answer is 1, and minus 1 is a constant value, so its derivative will be 0. So del f by del y, that is equals to 3x plus 1. Now again we have to find out del f by del y at point 4 comma minus 5. So in del f by del y we will replace x by 4 and y by minus 5. So this is equals to 3 into 4 plus 1. 3 into 4 is 12 plus 1, so answer is 13. Now we will see example 3 related to this topic. If u equals to logarithm of 10x plus 10y plus 10z, then we have to prove that sine 2x into del u by del x plus sine 2y into del u by del y plus sine 2z into del u by del z, that is equals to 2. So here u equals to logarithm of 10x plus 10y plus 10z. So first of all we will find out del u by del x. So del u by del x, that is equals to, all of you know that derivative of log x, answer is 1 upon x. But here we have logarithm of 10x plus 10y plus 10z. So derivative of logarithm of 10x plus 10y 10 plus 10z, that is equals to 1 over 10x plus 10y plus 10z. But in place of x we have 10x plus 10y plus 10z. So again we will differentiate 10x plus 10y plus 10z with respect to x, partially keeping y and z constant. So derivative of 10x, answer is sec square x, and derivative of 10y and 10z will be 0, multiplying del u by del x by sine 2x. So sine 2x into del u by del x, that is equals to, all of you know that sine 2x is 2 sine x into cos x, and sec square x is 1 over cos square x, and divided by 10x plus 10y plus 10z. Now cos x one time will cancel out. So we have 2 sin x over cos x, so the result is 2 tan x upon 10x plus 10y plus 10z. Now similarly, we can find out sin 2y into del u by del y. In case of sin 2x del u by del x, in the numerator we have 2 tan x. So in case of sin 2y del u by del y, we will be having 2 tan y in the numerator. So sin 2y del u by del y, that is equals to 2 tan y upon 10x plus 10y plus 10z. Now similarly, sin 2z into del u by del z, that is equals to 2 tan z upon 10x plus 10y plus 10z. Now we will add all the three results, that is sine 2x into del u by del x plus sine 2y into del u by del y plus sine 2z into del u by del z. And sine 2x del u by del x is 2 tan x over tan x plus tan y plus tan z. Sine 2y into del u by del y, that is 2 tan y over tan x plus tan y plus tan z. And sine 2z del u by del z, that is 2 tan z over tan x plus tan y plus tan z. Now taking LCM, tan x plus tan y plus tan z, in the numerator we will be having 2 tan x plus 2 tan y plus 2 tan z. Now taking 2 common from the numerator, so we have 2 into bracket tan x plus tan y plus tan z and divided by tan x plus tan y plus tan z. So tan x plus tan y plus tan z will cancel out from the numerator and denominator, and the result is 2. So this is the result of sine 2x del u by del x plus sine 2y del u by del y plus sine 2z del u by del z, and answer is 2. So in today's lecture we have discussed what is first order partial derivative and examples related to this topic. Thank you for watching this video. I will see you in the next lecture.